In this video, we're going to be discussing Lab 9, chemical reaction types and their equations. So there are basically 4 types of chemical reactions that we're going to be discussing in this lab. The first is synthesis. Now, synthesis is where you have one or more reactants and you form a single product, right? So an example would be magnesium, or any metal for that matter, combining with oxygen, forming magnesium oxide. So you have two reactants and a single product. Decomposition is the exact opposite of synthesis. Here you have one single reactant and it's breaking up to give you 2 or more products, like in the case of hydrogen peroxide, it's decomposing to form water and oxygen. Single displacement is where a metal dissolves into the acid, and then the metal actually takes the place of hydrogen in the acid. So it pushes out the hydrogen, and those 2 hydrogen atoms come out in the form of hydrogen gas. And so here zinc has taken the place of hydrogen, forming zinc chloride. Okay? And then you have double displacement, where basically the cations and the anions exchange with each other. So silver combines with chloride, extreme left to extreme right, and then the 2 in the middle, the sodium and the nitrate, come together to form sodium nitrate. Now, in double displacement, the way you can tell that a reaction has happened is a solid, like a precipitate, forms in the like you can see here. Silver chloride doesn't stay in solution, it comes out of solution, it's insoluble. Sometimes gas formation occurs. So those are indicators that a chemical reaction has happened. All right. So a chemical reaction is basically when you have an equation that represents the reaction. It's kind of a roadmap, all right? It tells you what the reactants are, which is on the left side. You have an arrow which indicates the direction of the reaction. The arrowhead is pointing towards the products. Products are on the right side of the the arrow in the equation. And then the other information that you can also get from an equation is the states of the reactants and products. So when you have the parenthesis lowercase s, it's solid. This is a gas. When you see an L, that's a liquid. And when you see AQ, that means dissolved into water or aqueous solution, right? So you can see clearly that the silver chloride is not dissolved into water. It comes out of solution in the form of a precipitate. Okay. So the equation is kind of the roadmap. It tells you what is happening in the reaction. Hydrates. What are hydrates? So hydrates are ionic compounds. They have a crystal structure, and inside the crystal structure you'll see water molecules present. Okay. So one such hydrate, copper 2 sulfate pentahydrate. So copper 2 sulfate, within its crystal structure there are 5 water molecules attached to the copper ion, right? So each molecule of copper 2 sulfate has 5 molecules of water attached to it. These are physical bonds. However, these are loosely attached. So when you heat up that hydrate, what will happen is those bonds will be broken and the water will then vaporize and come out as water vapor, and eventually it will condense into liquid water. All right. So the hydrate has got a blue crystalline structure, very pretty. And then when you heat it, as the water leaves it, what's left behind is the anhydrate. An means without water, and that's a white colored powdery looking substance. It doesn't have that clear crystal structure like the hydrate. So here are some pictures showing you that. You can see that this is the copper ion. It's very there is an ionic charge that binds it to the sulfate polyatomic ion. This S is sulfur. The yellow colored ball is the sulfur, and you can see that the water, this is oxygen, the negative oxygen is attracted to the positive copper ion. And so you have 5 of these water molecules that are kind of loosely bound to the copper. All right, all you can see here is 4, but here you can again see 4, but there's one other water that is bound to the copper. All right, so they kind of form this nice network which gives it that crystal structure and that blue color to the hydrate. And then once you start heating the hydrate, the water starts leaving it, it vaporizes out, and you'll get that white stuff, which is the anhydrate, just the copper 2 sulfate, right? So when you complete the heating process, it's no longer blue in color, it's white. So in the first reaction, you're doing a synthesis. You're taking an empty crucible and massing it. Its mass should be around 88 grams. Now to this you're adding 5 grams of the magnesium metal, so of course the mass is going to go up to 93 grams. You're now taking the magnesium and the crucible, putting it on a Bunsen burner and heating it for at least 2 minutes. Okay, and then you bring the whole setup onto the workbench, cool it for 2 minutes, and then mass it again. Now the mass would have gone up now because of the presence of oxygen. Now again, take another clean crucible, mass it. Again, crucibles are around 88 grams. To it you're adding 5 grams of the copper 1 carbonate hydroxide monohydrate. So this is an interesting hydrate. You have the copper 1 carbonate and a hydroxide, and then you have that water. Now this is called as water of crystallization because you're showing that the water molecules are not part of this the formula of the compound, rather it's kind of loosely bound to the cation, and so you are showing the water of hydration separated from the formula of the compound by a little dot here, right? So you have 1 water of crystallization for this 1 molecule of this compound, and that's green in color. So this hydrate is green in color, and then you're going to heat it and it'll change color. Now, unlike the other hydrate which simply loses water, here it will lose this water as well as lose another molecule of water from this hydroxide part and carbon dioxide as well. So what will be left behind is the 2 coppers and 2 oxygen atoms, one from here and another one from here. All right, and that's copper 2 oxide, which is black in color. So the anhydrate is without water and without carbon dioxide, and it's black in color. So from green you go to a black colored substance when you heat this hydrate. In the third experiment, you're taking an Erlenmeyer flask. To it you're adding 15 mils of hydrochloric acid, and then make sure to click on the flask and close it, stopper it. So you have a closed system now. You'll attach a thermometer as well as a pressure gauge. This is because the gas is going to collect inside the flask, and you're going to record the pressure of the gas as it accumulates. So to this flask you're now adding 0.25 grams of the metal, and then the reaction between the metal and the acid will start, and the flask, this is highly exothermic, so the flask will get heated up. Wait till the temperature cools down to room temperature, which is 21.5 degrees centigrade. Then you're going to connect a syringe to the flask. The gas inside the flask will escape into the syringe. So find out what that volume of the gas in the syringe is. You don't have to click on the syringe, just roll your mouse over it, and you can see the volume appearing. In the fourth experiment, it's double displacement. So you're taking two beakers. One will have 15 ml of sodium hydroxide. The other would have the 6 ml of nickel 2 chloride. So click on those beakers to label them. Make a note of what the contents look like, what the colors are, and the transparency. Transparency is it transparent to light? Is it cloudy or is it clear? Okay. And then you're going to mix one of the beakers into the other, so that to mix the contents, and then again record your observations. So this time you are going to check again to see what if ever if there's a color change, and also the transparency. If there is a cloudiness, that means that there is a solid precipitate that is forming and coming out of solution. So for the first experiment, these are the data. Empty crucible 88 grams. When you add the 5 grams of magnesium, the mass will go up to 93 grams. So if this is labeled as A and this is B, A plus B, that will be 93 grams. After heating, the mass goes up, as you can see, to 96.289. So 96.289 minus 93, and that would give you 3.289. So this is basically the mass of the oxygen. Okay. Why do I say that? Because this is the mass of the magnesium. This is the mass of the magnesium oxide. If you subtract one from the other, you get the mass of oxygen. So the mass of oxygen formed is 3.289 grams. Okay. The balanced equation for this reaction is 2 moles of Mg, 1 mole of oxygen, giving you 2 moles of MgO. The second experiment is the copper 1 carbonate hydroxide hydrate. So this is like a green powdery or crystalline substance, and you will heat it up. The triangle is a symbol for heat, and you can see that there are 2 molecules of water coming out as well as 1 molecule of carbon dioxide. What's left behind is the 2 molecules of copper 2 oxide, which is a black powder. So this hydrate that you took was about 5 grams. All right, crucible is 88. 88 plus 5, that's 93 grams. Once you heated it, the mass comes down because you've lost water and carbon dioxide. So the mass has come down to 91.327. If you subtract the mass of that empty crucible out of it, then you get 3.327. That's the mass of the anhydrate, the copper 2 oxide that's left behind. Okay. And then we'll stop here, and I'll continue this in the next video.